Hey guys, welcome back to my channel. In this video, we'll be doing question 2 from class 12 HSCs, chapter 3, exercise 3.1, that is indefinite integration. This is from mathematics and statistics part 2. So let's get started. Basically, in this one, you have to integrate the functions that are put forth before you. Very easy question, will be over before you know it, because if you know the basic integrations, right? So what's the integration of some basic terms, then you'll be able to solve this very easily. Now first question is tan square x. There is no integration of tan square x. We do have an integration of sec square x. Now we can write tan square x as sec square x minus 1. So we'll write this as integration of sec square x minus 1 dx. We all know that integration can be broken down. So we break it into sec square x dx minus integral of dx. We can write this as the integration of sec square x is tan x. Tan x. And integration of dx is minus, and integration of dx is x, and you add the integration constant c. That's your answer. Moving on to the second sub question, sine 2x upon cos x. Play with it a bit. We know trigonometry, right? Sine 2x can be written as 2 sine x cos x upon cos x will be written as it is. Cancel off the 2. Don't forget the dx. What do you get? 2 integration of sine x dx. What is the integration of sine x? The integration of sine x is minus cos x. So you get minus 2 cos x plus c. Plus c is compulsory, the integration constant. Why? Like I explained in one of my previous videos, you are getting integration by doing the reverse of differentiation. In differentiation, a constant on differentiating becomes 0. You don't want to miss out on that constant because the function will completely change if you miss out on a constant. So to make sure that the constant that is become a 0 is considered, now that constant can be anything, right? The constant can also be 0. So that constant is c. Okay, moving on. Sin x by cos square x. You can write this as sin x by cos x and take the other cos x up. So sin x by cos x is tan x, and taking the other cos x up, you have sec x. So it becomes integration of sec x tan x dx. The integration of sec x tan x is sec x. So is equal to sec x plus c. Moving on to the fourth sub question, you have cos square x upon sin square x. Cos 2x upon sin square x. Again, play with it a bit like you did in this question. Cos 2x can be written as cos square x minus sin square x. Now instead of writing that as cos square x upon sin square x, let's write it as 1 minus sin square x. So you have 1 minus 2 sin square x. 1 minus 2 sin square x upon sin square x dx. Breaking it down, you have 1 as 1 upon sin square x dx, or dx upon sin square x, minus 2 under root sin square x upon sin square x dx. Sin square cancel off, so that's just dx. So let's simplify that and write. On simplifying this, 1 upon sin square x becomes integration of cosec square x. So integral cosec square x dx minus 2 into integral of dx. Integral of cosec square x is minus cot x. Minus 2 integral of dx can be written as minus 2x, and plus your integration constant. That's your answer. Moving on to the next question. So here we have the fifth sub question. It says cos 2x upon sin square x cos square x. Now, in the previous one we wrote cos 2x as 1 minus 2 sin square x. Cos 2x can also be written as cos square x minus sin square x. So having that written down, cos 2x is cos square x minus sin square x upon sin square x cos square x. Adding the dx, you can write it as cos square x upon sin square x cos square x That means you're just breaking down the integration dx here minus integral of sine square x by sine square x cos square x dx. Cos square x cancels off with cos square x, sine square x cancels off with sine square x. So what you have here is integration of 1 by sine square x is cosec square x dx minus integral of sec square x dx. So cosec square x is directly integrated as tan x, sorry, cosec square is directly integrated as minus cot x. You have minus cot x, and sec square x is integrated as tan x minus tan x plus c, that is your integration constant. Moving on to the sixth sub question, you have sin x upon 1 minus sin x. Remember how we used to make sure that there's only one term in the base in our grades 9 and 10. To make that, what we would do is we would just multiply the base with the conjugate, right? So what you will do here is multiply both the numerator and denominator by 1 minus sin x. So 1 plus sin x by sin x times 1 minus sin x upon 1 minus sin x. So that gives you, so don't forget the integral dx over here. So integral of sin x minus sin square x upon 1 minus sin square x. Why so? Because a plus b into a minus b is a square minus b square. Adding the dx. Now this can also be written as sin x minus sin square x upon cos square x dx. Now you can break down the integration as sin x by cos square x dx minus integral of sin square x upon cos square x dx. What you can write that as is sin x cos x cos square, sin x by cos square x can be written as sec x tan x. So sec x tan x dx minus sin square by cos square is written as tan square x dx. We already did the integration of tan square x dx, where we found it out to be tan x minus x plus c, and sec x tan x integration is the same as sec x. So sec x and minus tan square x. Tan square x is integrated as tan x minus x. So minus tan x plus x plus c, the integration constant. Moving on to question number 7. So here's question number 7. Tan x by sec x plus tan x. Now sec x plus tan x, we can do the same thing we did in the previous question here as well. So you'll just multiply by its conjugate in the denominator. So you have sec x plus tan x in the denominator, tan x in the numerator. Multiply that by sec x minus tan x upon sec x minus tan x dx. Now you can write that as sec x tan x minus tan square x upon sec square x minus tan square x. So you can write that as integral of sec square x minus tan square x is 1. So that is sec x tan x minus tan square x into dx. Break that down into sec x tan x dx minus integral of tan square x dx. Now this is just like the previous question. You have sec x tan x dx minus tan square x dx. So the answer as well will be same here. Sec x minus tan x plus c plus x plus c. Now here I am directly writing the differentiation of tan square x as this. You should not do that. In your exam you have to derive it completely, because over there you're not having inference from your question number 1. You're directly solving this question. So you have to show it step by step. Break it down into sec square x minus 1. Then differentiate sec square x, differentiate 1. Then get your answer. Don't just directly write your answer like I have. Moving on to question number 8. So question number 8, you have 1 minus 2 sine x. Now again, play with this here. You know everything about trigonometry. 1 can be written as sine square x plus cos square x. And 2 sine x can be written as 2 sine x cos x into dx. Now if you look at it, sine square x plus cos square x plus 2 sine x cos x. Doesn't ring a bell? No worries. Let's write sine as a, cos as b. That gives you a square plus b square plus 2ab. What does that remind you of? A plus b the whole square, correct? So what will we write that as? We'll write it as under root of sine x plus cos x the whole square. Now under root and square cancel each other off. So you just write it as the integration of sine x plus cos x and add the dx here. You can write this as integral of sine x dx plus integral of cos x dx. Integral of sine x is minus cos x. Integral of cos x is sine x. And don't forget to add your integration constants, that is c. Moving on to question number 9. Right. So you have 1 minus under root cos 2x. Okay. Now again, like in the previous question, let's just expand everything, correct? So you have integral of 1 can again be written as sine square x plus cos square x minus cos 2x is cos square x minus sine square x. So we'll write that as minus cos square x plus sine square x, because there's a minus before it. Under root, let's not forget the dx here. So cos square x cancel each other off, and you have 2 sine x, integral of under root 2 sine square x dx. That can be written as integral of under root 2 sine x dx. Under root 2 moves out, so under root 2 integral of sine x dx. Integral of sine x, like we all know, is minus cos x. So minus root 2 cos x dx. Cos x plus c. We already integrated, so no more dx, just a c. That's your answer for question number 9. Moving on to the 10th and the last sub question of this video, this question. Sine 4x plus sine 4x into cos 3x. Now, if you think of it, a b, let 4x be a and 3x be b, right? Sine a cos b, had it had a 2 before it, it would make the form 2 sine a cos b. So let's just add a 2 before it. So multiplying divide by 2, you get half 2 sine 4x cos 3x dx. 2 sine a cos b is sine a plus b plus sine a minus b. So let's write that as minus 1 by 2 integral of sine 4x plus 3x is a 7x plus sine 4x minus 3x is an x, integral of dx. Now you have sine 7x over here equal to 1 upon sine 7x integral, also half integral sine 7x dx plus half integral of sine x dx. equals 1 by 2 sine 7x, integration of sine x is cos x, so minus cos 7x upon 7. So sine ax will be integrated as cos ax upon a, plus half, and sine x can directly be minus cos x. Don't forget to add the c. So what is it now? Minus cos 7x upon 14 minus cos x upon 2 plus c. And that's it. That's your answer. So guys, that's it for the video. Don't forget to like, share and subscribe. Comment down below if you have any more suggestions or questions. And yeah, and if you don't have a list of all the integrations that you should have, don't forget to mention in the comments. I'll be sure to make a short about it. So that's it for the video. Don't forget to like, share, subscribe, comment down below, and thanks for watching.